Hello, my name is Matthew Nazzle. I'm going to be talking to you about my project. So, let's begin. What is the mortality rate due to COVID-19 of people in California with underlying conditions versus those without? Is there statistically a significant difference between the mortality rates of those with conditions and those with underlying health conditions? This is important to your average person who is worried about coronavirus. So the target audience I'm trying to reach outwards to is basically the average person, those who are just worried and concerned or living with elderly people, or they have relatives that may be going through this, so it's to anyone. If the ratio with people with underlying health conditions versus those without is very high, this means that a person who has no underlying health conditions may not have to worry about getting coronavirus. However, those who do have, and those who live with people who do have COVID-19 will have an increased chance of getting coronavirus, according to Fox News' Madeline Farber. The probability sampling method I'll use is cluster sampling because I'm dealing with large population, California, and I will be using varying counties such as Los Angeles, Ventura, etc. So a simple random sample from each of these counties with the number of people selected will be proportional to the state's population that the county makes up. And I could do this through a mailed survey, and to structure how many letters we'll need to send, we'll do that by tallying up the numbers of addresses of people who reside within each of those counties. The pros are, the sample will allow me to get a better indication of the population's mortality rate between COVID-19 and people with underlying health conditions. Also, it would be great use to get precise results. Cons, not everyone in the survey will respond, and this means that the results will have to be compensated by gathering the total number of responses and the number of surveys that were left unanswered. Now, just an FYI, this is what I wrote in my essay. However, I cannot find data on this hypothesis. So instead, I changed the question. So this is the new hypothesis. The sample I am interested in is knowing what the mortality rate due to COVID-19 of people in California with positive patients versus suspected patients. And is there a statistically significant difference between the mortality rates? Now, I am using the same sampling method. I'm still using the same cluster sample in this hypothesis. And I retrieved this data through the WHO organization.
Now this is my qualitative variable. If you look on my project part 2, you'll see the chart. However, I cannot bring that up for some reason. My computer's being whacked.
This is my first qualitative variable. It's the depiction of deaths by gender in CA according to this pie chart above, which depicts the deaths percentage ratio between males, females, and unknown genders in the state of California. The proportion of males that died from COVID-19 is at 56, and the proportion of females that have died of COVID-19 is 43.70, while unknown is at 0.10. So basically all of this adds up to 100, and that's estimating the deaths for gender in California's population. And this is my quantitative variable, suspected hospital patients. Here's a box plot. This is my median, my quartile 1, and this is the outliers right here. The suspected hospital patients per 100,000 population. So the shape is greater than the median, making the distribution skewed right. The mean is pulled in the direction of higher values. So it's pulled in the direction of the outliers which have higher values. With this in the center describes the mean with 25 and its median at 1. The spread, the box plot has an upper extreme of 653 and a lower of 0. So meaning the highest number of suspected patients is at 653. The IQR is 16. The outliers are derived from counties with higher populations, which means there is a greater possibility to be suspected of catching COVID-19. Especially because of the larger populations, they have more busier areas, they're more densely populated, so there's an increased possibility for crowded counties to have more patients who are suspected with COVID-19 than counties with lower amounts of people in their population. And the 5-number summary is the lower extreme 0, quartile 1 is at 0, median's at 1, quartile 3 is 16, upper extreme at 653. Second quantitative variable is positive hospital patients, and we can see the same kind of outline here, so it's going to kind of match. Positive hospital patients is, the mean of positive hospital patients is greater than the median because the distribution is skewed right, meaning it's pulled towards outliers which have higher values. However, the center is different. The mean is 96, and its median is at 9. The box plot has an upper extreme of 1,921 and a lower extreme of 0. Spread of 1,921. So there's a total of 1,921 positive patients in Los Angeles because that's the one that had the most highest positive patients. The IQR is a 78, and we will talk about the outliers are due to a large amount of people within those populations, which results in overall infected with coronavirus resulting in more people overall infected with coronavirus who need hospitalization compared to counties with fewer. So the 5-number summary is lower extreme 0, quartile 1 0, median 9, quartile 3 78, upper extreme 1,921. Death box plot, they are the same, except the lower extreme is 0, quartile 0, median's 4, quartile 3 is 55, upper extreme 3,454, because Los Angeles has the most deaths out of all counties per 100,000. So the shape is greater than the median, and the distribution skewed right. It's going to follow the same kind of pattern as the last two have, with a center mean of 110, median 4. Because it is skewed right, will be pulled towards higher numbers, with minimum 0, maximum at 3,454, because you can either get a minimum of 0 positive cases or 3,454, just as LA. Now here's my scatter plot regression line. And so part 4 of the project really is about the scatter plots. So when you first look at this was originally from part 3, but I extracted that graph and I took a look. I'm like, you know what? I want to test I want to have a hypothesis test for patients who tested positive versus the number of patients who were suspected of having COVID-19. And you can see there's a big gap between the outliers. This is LA, actually, and this is Orange County. But that's like ridiculous. So the slope explains that for every 1 additional patient, we have 3.038 additional positive hospital patients. The rate seems to be 1 through 3, which was determined from the slope. However, as I looked at this, it has a strong linear correlation of 0.98. And the alpha I've been using is 0.05 for all of these, just so you know. The intercept is meaningless because it is in the range of 0. And knowing that, what if we remove the highest outlier among the scatter plot of hypothesis test 1? So what if we removed this guy here? Would the slope show any significant changes or major differences? This is that change without LA County. So here we are, hypothesis test 1A. So as you can tell, it's more spread out. The outliers, you can kind of get it's a better looking graph. It has an R correlation coefficient of 0.95. However, the slope only increased by 1. So let's talk about that. The value of the slope is 4.07, which is significantly greater than 0 because the significance level of 0.05 is above the p-value of less than 0.0001. For every 1 additional hospital patient, we have 4.07 additional positive patients. The rate seems to be 4, which was determined from the slope. Compare and contrast between hypothesis test 1 and 1A. I removed one of the most extreme outliers from the sample, Los Angeles, as the current data I possess does not give me the freedom or ability to find type 1 or 2 errors. Now, in comparing the two slopes and scatter plots, the slope estimate does not appear too big of a change to be significant enough to support the idea that COVID-19, that LA County is an epicenter or breeding ground for positive or suspected patients. Because if you look, for hypothesis test 1, it was at slope 3.03, whereas hypothesis test 1A is slope of 4.07. So slope goes 3 to 4, which is not dramatic effect. It doesn't lead to a dramatic effect. The correlation coefficient remains approximately the same. Even though it changes the picture dramatically, it still doesn't change the conclusion that positive and suspected patients are more likely to occur with or without the county of LA. And then here's my confidence interval. What is the proportion of deaths to positive patients? And we could tell that this is what it looks like here. This is LA. These are the other counties. These are kind of my stats. And so we're not looking at the intercept because it's not as important really. We are 95% confident that the slope is between the lower limit of 1.464 and the upper limit of 1.722. The confidence interval does not capture 0. Therefore, the slope is significantly greater than 0. And for hypothesis test 2, what is the relationship between the suspected hospital patients and the total deaths? Here's our slope with 5, and the p-value is less than 0.0001. The value of the slope is 5.05, which is significantly greater than 0 because the significance level of 0.05 is above the p-value of less than 0.01.
That was it. Finishing end of my project part 4. Professor, I hope you have a really good semester and great year. Hope to see you back at school maybe once this whole ordeal is over with.